Lesson 5-6, Inequalities in one triangle. Here's a picture with the angles labeled 1, 2, and 3 on the inside of the triangle and angle 4 on the outside. Which angle is the exterior angle? I would say angle 4 is on the outside of that triangle. What does the exterior angle equal? Well, we had exterior angle theorem in a previous chapter, and the measure of angle 4 was equal to the measure of angle 1 plus the measure of angle 2. The reason for that is that we know that 3 plus 4 is 180 because of the linear pair postulate. Then, by the triangle sum theorem, we know that 1 plus 2 plus 3 is 180. If they're both equal to 180, then they're equal to each other. Then what we can do is, because there's on a 3 on both sides of the equal sign, we can subtract it off, and we're left with the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Angles 1 and angle 2 are called remote interior angles. The corollary to the exterior angle theorem. The measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. So the exterior angle is angle 1. Angle 1 is greater than the measure of angle 3, and angle 1 is greater than the measure of angle 2. So those are the remote interior angles. Theorem 510. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So in this case, the measure of angle y is got to be greater than the measure of angle z. So this side, the red side, is going to be longer than the blue side. So that means that xz, that distance, has got to be greater than xy. So let's try some examples using these. Is the measure of angle 2 larger than the measure of angle 3? Well, the first thing that I notice about my picture is that this makes an isosceles triangle. So whatever angle 2 is, angle 1 must be the same. So I'm going to write that down so I remember it. The reasoning for that is the base angles theorem. Then if I focus in on this part of the picture, I covered up a bunch of that stuff, then I notice that angle 1 is an exterior angle and angle 3 and 4 are remote interior. So then what I know is that the measure of that exterior angle has to be greater than the measure of angle 3, and it has to be greater than the measure of angle 4. And we already know that 1 and 2 are the exact same because we have that isosceles triangle. So then we can substitute 2 in here and 2 in here. And the one we're focused on is 2 larger than 3. So we're going to work on this piece right here. So if I rewrite that, I'm going to substitute in the measure of angle 2. It is greater than the measure of angle 3. So is it greater than? Yes, it is. And remember, angle 2 would be a base angle of that isosceles triangle. So let's try an example together. Name the side of the triangle from shortest to longest. So what I'm going to do is write the angles in order. So I have 58 degrees, 60 degrees, and 62 degrees. If I flip back a couple of sides, we are talking about Theorem 510. Theorem 510 says if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So the bigger the angle, the bigger the side is opposite it. So what that means is the biggest angle is 62, so then the side opposite has to be the biggest. So that's going to be UT. Then opposite of 60 is UV, and opposite the smallest angle is TV. So if we put the angles in order, then if we put the sides opposite them in order, they will go from shortest to longest. And notice how I don't have the segment bar on top, because when I write it like this, that actually stands for the length from T to V. Try the next problem on your own. Please pause the video while you work. So I'm going to order my side lengths from smallest to largest. Opposite the side 3 would be angle F. Opposite the side 5 is angle X. And opposite the 10 is angle O. So that is from smallest to largest. Let's try a real-world problem. A town park is triangular. A landscape architect wants to place a bench at the corner where the largest angle lies. Which two streets form the corner with the largest angle? Well, the largest side is 175, so then the largest angle would be over here. So we want to be on the corner of MLK Boulevard and Valley Road. Here's our next topic. For any three segments to form a triangle, their lengths must be related in a certain way. Notice that only one set of segments below can form a triangle. So in the first picture, we have a 3, 3, 5 triangle. In the second picture, we have a 2, 2, 6 piece that doesn't actually close, because if I draw those out, this 2 would lay straight on top, the 2 would lay straight on top. If I draw this color in green, they would never touch. So we would either have to make it a four-sided figure or extend these other two legs to make that happen. So we're trying to think about what can we conclude about the sides of a triangle so that we can make a triangle. Let's look at this diagram. It says AC plus BC, and then it gives the measurements of the side. So this is a Geometry Sketchpad type of software. So if I grab point C, notice this side and this side right now add to 40, and the side AB is 30. So if I drag over here, I'm at 47. If I drag here, I'm at 32. And if I go towards, I get really close to 30, but that's about as far as I can go. So hopefully this illustration kind of helps you see what relationship we have to have. And I know those numbers are pretty small unless you're watching it on your computer. But what happens is the sum of the lengths of any two sides of a right triangle, or of a triangle, have to be greater than the length of the third side. So looking at our picture, yours is not color-coded, so bear with me. Red plus blue has to be greater than the purple side. Blue plus purple has to be greater than the red side. Purple plus red has to be bigger than the blue side. Those three items have to be true for you to draw a triangle. If that isn't true, then your sides are not long enough to make a triangle. So take a look at this sketch. My base is 10.3 centimeters. I have a leg that's 4.3 and 2.4. So this up here calculates and adds these two numbers together. Right now I'm smaller than 10. So if I keep that the same length, and I know I'm not going to be exactly the same, 2.54, and move it down here, and if I move this 4.37 down here, so 4.37, okay, there's no way that those two legs can connect. The only way they can connect is if this number or those two lengths added together are bigger than 10. Because if I connect right now, I'm at 10.07. And if I connect over here, then I'm at about 10.08. Okay, so that also proves the triangle inequality theorem, that two sides always have to add up to be bigger than the third. So let's apply this knowledge. Can the triangles have the given lengths? So part A, here's what you would do. In your head you're thinking, or on paper, 3 plus 7 has to be bigger than 8. 10 is bigger than 8, so that works. 7 plus 8 has to be bigger than 3. 15 is bigger than 3. 3 plus 8 has to be bigger than 7. 11 is bigger than 7. So because all of those inequalities work, this would be a yes. Let's try another one. Here we have a triangle with sides 5, 10, and 15, so it's scalene. All three sides are different. So by triangle inequality, we add two sides together and they have to be bigger than a third. So I'm going to do 5 plus 10 has to be greater than 15. That is false. So right away, I know that no, that's not going to work. If I kept going, 10 plus 15 is greater than 5, and 15 plus 5 is greater than 10. But that one piece didn't work, so then this one is a no. In the last one, 2 plus 6 has to be greater than 9, and right away we're at a no. So then no, this cannot form a triangle. So then what we have to do over here on the right is the lengths of the two sides are given. Find the range of the possible lengths for the third side. So we're going to be writing an inequality. So we'll call that third side x. So our equations are going to be x plus 8 has to be greater than 12. 8 plus 12 has to be greater than x. And 12 plus x has to be greater than 8. So we need to simplify these. So if I subtract 8, I get x is greater than 4. If I simplify, I get 20 is greater than x. If I subtract 12, I get x is greater than negative 4. So this one needs to be switched. So if I switch my order, I have to switch my sign. So these are our stipulations. We need to be greater than 4, we need to be less than 20, and we need to be greater than negative 4. Well, we can't do negative numbers, and we have to be all three of these inequalities. So there are some numbers that don't work here that need to work. So we're not going to use that one. We're going to use these two because this does not include all of the numbers in this set, where the inequality has to be satisfied by all these numbers. Because a number that's less than 20, like 19, would have to be greater than 4, which it is. So we want numbers that are less than 20 and greater than 4. So these two written together, this is a compound inequality. This would be an and. So they always have to be less than symbols. You put your smaller number on the left, your bigger number on the right. This concludes my lesson on the triangle inequality.